This talk is to present our CSCW 2020 paper, Designing Alternative Representations of Confusion Matrices to Support Non-Expert Public Understanding of Algorithm Performance. My name is Shen. I'm a system scientist at Carnegie Mellon University. This work is a collaborative effort with my co-authors Haojian, Alex Cabrera, Adam Pura, Haiyi, and Jason Hong. Imagine you're a journalist who needs to write a story covering issues of differential treatment of two demographic groups by a recidivism prediction algorithm in order to generate informed public debate. This is exactly what ProPublica tried to do in their very influential story, Machine Bias, back in 2016. This task is not easy, as members from the general public often lack the technical background required to understand the relatively complicated terms and the performance of the underlying machine learning models. So our project is actually set up towards this rather ambitious goal, that is, to develop non-expert-oriented toolkit to support public understanding and debate of AI performance. In this research, we focused on redesigning confusion matrices as a first step. Confusion matrix is a widely used tool in machine learning to communicate the performance of a classifier on a set of training or test data when the ground truth is known. In this research, we conducted two studies. Study 1 used the qualitative method to identify challenges laypeople have in understanding standard confusion matrices. Study 2, we used between subjects experiment to evaluate the effectiveness of 4 alternatives we designed for this project in terms of objective and subjective understanding and time costs. We have also developed an evaluation framework of objective understanding, which includes 3 types of questions: comprehension, comparison, and simulation. We used those questions in our following studies. In study 1, we presented our participants with the confusion matrices showed on this page, used the data ProPublica collected in 2016 in the context of recidivism prediction. We identified 2 sets of challenges our participants have. The first set is, in general, they are confused about terminologies such as false positives. The second set of challenges is they are confused about the underlying relationship between the 4 types of predictions. We have further identified 3 sub-challenges here. They are confused about direction of reading the data, they are confused about the layered relations, and they are confused about the quantities involved. We then conducted a design workshop to design 4 different alternatives to tackle those challenges one by one. We used a contextualized confusion matrices to contextualize all the terminologies. We used a tree diagram to unpack layered relations. We used a flowchart to point out the direction of reading the data, and then we used a bar chart to clarify the quantity involved. After the design workshop, we conducted study 2 to run an experiment on MTurk to evaluate their effectiveness. In analysis 1, we compared contextualized against standard confusion matrices. In analysis 2, we compared tree, flow, and bar against confusion matrices, all with contextualized terminologies. Here is our results. Our analysis 1 indicates that comparing contextualized terminologies and standard terminologies, contextualized significantly outperformed standard ones, both in objective understanding and subjective understanding. Our analysis 2 further suggested that all using contextualized terminologies, only flowchart outperformed the contextualized confusion matrix in terms of overall objective understanding. So here are our main findings. Contextualizing terminologies can significantly improve users' objective and subjective understanding. And the flowcharts that point out the direction of reading the data were most useful in improving objective understanding, though its level of subjective understanding was not improving. If you are interested, feel free to read into our paper in the ACM Digital Library. Thank you.